Enzymes. Enzymes are proteins, and what these proteins do is that they speed up chemical reactions. So whatever reaction is happening in the cell, and it will take 3, 4, 5, 6 hours, enzyme can make it work in minutes. What enzymes do, however, is that they do not change anything else. So they speed the reaction up, but they do not change anything else. So they don't affect anything. So that's why our body utilizes enzyme, because all it does is just speed the reaction up and it goes along its way. So enzymes are specific also, in that if I were to combine these two molecules together, and if I use enzyme X, it will work. However, if I decided to put enzyme Y, it will not work. So they're very specific. So what makes enzymes so specific is that they have something called an active site. So this is your enzyme, and this is what is going to cause the reaction to go faster. The active site have a specific shape, and the substrate must have a specific shape. It's like a lock and key model. It often is used in science to describe an enzyme. If you have a lock and you have a key that is of the same shape, it will fit and it will work. If you have a lock and it has a key like that, it will not work. So enzymes work similarly. They have an active site and they have a substrate that must match. And if they do not match, the reaction will not happen. Similarly here, you can see. The diagram looks a little bit confusing, but trust me, it's very simple. So this is your enzyme. We're going to look at this enzyme first. Of all these shapes, which one would fit into this enzyme? Yes, that and that. However, this this reactant or substrate and this would have no effect on that enzyme. It would not work because it does not match the shape. So enzyme is very specific with the certain substrate. And substrate is referred to as what it's reacting to. Since enzymes are proteins, they are affected by pH. I mentioned this in a few lessons ago that proteins are affected by pH. And they can only work at a certain pH. Once this pH is changed, it stopped working. So if we have enzyme Y and enzyme X, enzyme Y would work best at pH 2. Enzyme X would work best at pH 7. If I were to take enzyme X and I were to put it into a pH of 2, it will not work. And this is what's going to happen. Say this is your protein or your enzyme. Whenever I put it into the wrong pH, this is what's going to happen. And it's going to change its shape, and once it changes its shape, it will not work. So we must have the right pH before the enzyme can work. And again, I know you're looking forward to this slide. It's also affected by temperature. If we have a particular enzyme that will work with 35 degrees Celsius, it will work best. However, if we take the enzyme and we put it and give it 50 degrees Celsius, it will not work. The reaction will not happen. Most likely, the enzyme will be denatured. And I will write that word. So the enzyme will denature. Denature means change shape. Once it changes shape, it does not work. So just as a quick review, what do enzyme need in order to work? It must have a specific substrate. It must have the right pH, and it must have the right temperature. Once we have these things together, the enzyme will work perfectly. Speed up the chemical reaction. We're moving quickly into digestion. And digestion is where we're going to break all these molecules. We're going to break proteins, polypeptides of proteins. We're going to break long chains of carbohydrates or polysaccharides. We're going to break fatty acid and glycerol up together. And to break them up in a very fast way, we need enzymes. Some of the enzymes that we're going to look at in the next lesson, but I'm going to mention it here, is salivary amylase, pancreatic amylase, maltase. Right now I don't want you to remember these. However, what I want you to focus is that salivary amylase, which is in your mouth, needs a neutral pH. And if you can remember, neutral pH is about pH 7, it's halfway between 1 to 14. And it's not too acidic or not too basic. However, if we move into your pancreas, where you're going to produce pancreatic amylase, this enzyme needs a very basic condition. So it'll probably need a basic condition, anything that is above 7. Pepsin, and I mentioned this, which is produced by your gastric gland and is found in your stomach, is very acidic, and it needs a pH below 7. So again, this slide should not confuse you at all. All I want you to know from this slide is that there are several enzymes in our body, and they require a certain pH, a certain temperature, and a certain substrate. Different enzymes work at different parts in our body with different pH level. In our mouth, have a pH of 7, which is neutral, and salivary amylase will work best there. In our stomach, acetic acid is, pepsin is found, which is an enzyme, and it needs an acidic condition. If we put salivary amylase into our stomach, it would not work because the condition or the acidic or the pH level is not right.